In this section, we're going to discuss the case study of random characters. Since the character data type is numeric, the idea of computing a random character would be to call the math.rand function, multiply it by some value, and from that value, truncate it and wind up with a character. We have to ensure that the value, once truncated, falls in the proper range that represents an encoded character. The actual value of a character is non-intuitive. That is, we can't just simply think lowercase a has to have a certain value. There is a standard, and that's been explained before, the ASCII standard. It's expressed in the Unicode encoding of characters, and we know that A through Z is a sequence of numbers, but it may not always be clear to us exactly what those values are. Hopefully, we can get away from having to know the precise values. In this case, we need to know how many characters there are, although we as programmers know that there are 26 lowercase. But what if there were a slightly different number of them, or we were using a slightly different alphabet? We might not know. The computation here is take the final number in the sequence, that is lowercase z, subtract from it the first character in the sequence, lowercase a, then add 1. And that gives us the number of characters in that sequence. Now that's good and it works, but it's limited precisely to our alphabet. A better, more general way is to say take character 2, subtract from it character 1, add 1. That way we could use different alphabets, or we could come up with subranges. For example, how many characters are between the letters A and M? And that's, of course, half the alphabet. The first way of doing it, Z minus A, wouldn't allow us to answer that. We would have to come up with a separate computation. The more general pattern of character 2 minus character 1 would allow us to substitute M for character 2, A for character 1, subtract them, add 1, and come up with the answer 13. It works also with Z to A, that'd be 26. So that subrange is able to be computed by using a more general pattern. As has been said, that's the idea behind a good method, is to have a general algorithm that will solve the problem for any legitimate input data. In this section, the author says that there are 5 overloaded methods in the example, but regrettably, that's not true. There are only 2. An overloaded method, remember, has to have exactly the same name. 3 of those methods do not have the same name. The difference is there's a differing number, order, or type, or combination of parameters. That's the difference. Same name, different signature.